A pleasant day to all of you. My name is Anastasia and Soriana III, and today we're going to discuss about kinematics. But first, let us answer our drill. Okay, you got all the answers correctly. Now, let us proceed with the introduction. Okay, so kinematics is a branch of physics which studies motions of objects that doesn't refer or without reference to forces. Okay, so now, since it doesn't involve forces, we're going to tackle about the following. Okay, first is distance. Displacement, as well as speed and velocity. Okay, so let us first discuss what is distance and what is displacement. So you all know, or you may encounter this one, but distance is very different from displacement. Okay, so let us first discuss what is distance. Distance is the length of the path taken by an object in motion. Okay, so you got that? Okay, so to cite some example, I have here a illustration wherein distance is the dotted blue line. Okay, so that means that is the length of the pathway taken by the object from point A to point B, which is this curve. Okay, so it seems very long when we say distance because distance is a scalar quantity. So when we say scalar quantity, that is a quantity consists of magnitude or measurement. Okay, so displacement on the other hand is a vector quantity. Okay, when we say vector quantity, it includes magnitude as well as direction. Okay, so let us see our illustration again. Okay, so from this illustration, the displacement, regardless of which path was taken by the object in motion, is the length of point A to point B. That is the displacement. Okay, so that is their difference. Distance is the length of path taken by the object in motion, while the displacement is the direct length of point A to point B, or the initial, we call A as initial position and B as the final position. Okay, so you got that? Okay. Next, we have the speed and velocity. Okay, so speed and velocity are also different. Why? Because speed is a scalar quantity which refers to the distance covered by the object in motion at a time frame. Okay, so when we say speed, that is the distance covered by a moving object through its path through the current time. Okay, while velocity is a vector quantity. Okay, so same with speed, but it includes direction. Okay, so for example, okay, so you understand what is or what are those terms or terminologies means. Now, if we have a car, suppose we have a car moving along a straight path, okay, at a rate of 4 meters per second. Okay, so meaning to say this measurement 4 meters per second is the car's speed. Okay, since speed is a scalar quantity, it doesn't need direction. Okay, so with speed, we do not know where the car is going to. But with the arrow given, that is what we call a velocity. Okay, so its velocity now is 4 meters per second towards east. Okay, so that's how speed and velocity works. Okay, so now let us cite some examples. How are we going to know what is a speed or velocity of a moving object? Now, there is what we call an average speed and as well as average velocity. So now, let us take this average speed. Okay, so in order for us to know what the average speed of a moving object is, that is given by the formula S is equivalent to distance over time. Okay, S represents the speed, D the distance traveled, and T as the time being taken by the object moving. Okay, so let us try some example. Okay, so what is the speed? Sorry, what is the speed of a ball being kicked away if the distance covered is equivalent to 5 meters at a time frame t is equivalent to 3 seconds? Okay, so can we solve for the speed of the ball being kicked away? Okay, so that is a ball. So in order for us to solve this one, we use the formula speed is equivalent to distance covered over specified time. Okay, so in this case, the speed of the ball being thrown away or being kicked away is equivalent to distance covered, which is 5 meters, all over 3 seconds. Sorry, 3 seconds. Okay, so since this one is or cannot be simplified, it remains the same as 5 over 3 meter per second. By the way, meter per second is the usual unit for speed. Okay, so that is meter per second. But, okay, take note of this. Note sorry. Okay. Okay, so this note is very important. If one unit is in English unit, then it remains the same. What is it means? What does this mean? That if you have a measurement for length which is yards or in yards, and you have a time which is in minutes, then we can put it that way. Okay, so we do not have to convert yards into different measurements. We leave it as is. Yards per minute. Okay, you understand? Okay, very good. Okay, so let us cite another example so that you can apply this one. Okay. Example number 2. Okay, so what is the speed of a stone being thrown away in a horizontal motion? When we say horizontal motion, that is a single motion, okay, a linear motion. Okay, so this is the stone being thrown away at a distance equivalent to 13 yards. At time or t equivalent to 4 seconds. Okay, so let me rewrite this one. Okay, how are we going to know what is the speed of the stone? So, the formula S is equivalent to distance over time would be equivalent to the distance traveled by the stone, which is 13 yards, all over 4 seconds. Now, this is the important note I have written a while ago because yards is a English measurement or English unit. So, we do not convert it into meters. We just state it as is. But if the problem says that you need to convert it, then you need to convert yards into meters. Therefore, the speed of the stone is 13 yards, 13 over 4 yards per, 13 over 4 yards per second. Okay, so that's how speed or the speed formula works. Okay, now let us discuss, that is the average speed, by the way. Okay. Now let us discuss velocity. We said a while ago that velocity is the velocity is a what do you call this, vector quantity that deals with magnitude and direction. Okay, so velocity is the rate at which an object changes its position with respect to time frame. Okay, so have you understood that? Okay, so with this one, so average velocity. Okay, so velocity is a vector quantity. So therefore, displacement works to velocity, while distance works for speed. Okay, scalar to scalar, vector to vector quantities. Okay, so in velocity, to find the velocity or average velocity of an object moving along a horizontal path, then the formula is V is equivalent to change in position all over time frame. So what do you mean by change in position? A while ago, with this illustration, there is a change of position from point A to point B, given this vector or this line. Therefore, that is the change in position we are going to use, or sometimes referred to as displacement. Displacement over time frame. Okay, another formula or another formula to write is the same as this one, but you can use in final position minus initial position all over time. Okay, so again, velocity can be computed using these formulas. Okay, change in position all over time. Or if you do not have, or if you are being, what do you call this? If you are uncertain about the formula, you can use displacement over time or this one. Final position, okay, so x sub f refers to, x sub f refers to final position. Okay, so what do we mean by final position? That is the distance from the origin or the origin to the final position. Okay, while x sub 0 is the initial position. Initial position, or the starting point of the object being in motion. Okay, so let us try to use this one to solve the problem. Okay. Okay, so let us continue with an example. Okay, so suppose a man which have 4 different places to go, which is from point A to point B to point C to point D, with the time frame 0 minutes. So 0 minutes, so meaning to say at t is equal to 0, that is his initial position. So there he was on the first movement, and then as time goes by, 3 minutes after the initial position, there goes with the point B. Okay? Then, for the time frame 6 minutes, he goes into this place, which is point C. And then, for time frame 10 minutes, or after 10 minutes, he goes into this position. Okay? So, let us compute the average velocity. So, velocity can be displacement over time. Okay? So, this is our first solution. Okay? So, we must know what is the displacement of the man. Okay? So, in this case, the displacement of the man from point A to point D, we can count with the point system or the integer or the integral pointing system. So, as we can see from the origin going to this point, we have 10 yards. So, meaning to say, half of it is 5 yards. Therefore, one line is represented by 5 yards. Okay, so let us count. We have 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, and 55. Okay, so the displacement is equivalent to 55 yards. But displacement, okay, remember that displacement is consists of magnitude and direction. Okay, so if that's the case, we need to know what is the direction of the man moving onto these places. So from point A to point B, okay, so this man is going to the left. So we place the direction as left. Okay, divided by the time frame. So the time frame consists from initial time to the final time. Okay, so final time is 10 minutes. So initial time is 0. Therefore, we count the minutes from 0 to 10, and that is 10 minutes. Therefore, the average velocity of this man moving into these places is 55 divided by 10, that is 5.5. Okay? Or, let us use improper fraction first. So, we have 55 over 10 yards per minute going to the left. Okay? So, simplify, we have 11 over 2 yards per minute going to the left. Okay, so if you have scientific calculators, you can simplify this into 5.5 yards per minute left, going to the left. Okay, so that is all for today. Hope you enjoyed the lesson and learned something today. Goodbye and see you. Thank you for listening.